Hello everybody, so here is the fourth part of the tutorial about seq.list. You may have noticed at the end of the last vid there were like a little noise, a strange glitch, and it's because I'm recording myself doing that, the patching thing and playing with pure data, and as I'm on an old computer, it gets really quickly messy because of the CPU used. So, but even if you are on a really good computer, it's always a nice idea in computer music to have some way of stopping the audio processing. And in pure data, there is a good way to do that. It's to create, for example, subpatches. So you write pd space and then a name, so let's say kick. So you see there is this window which just opened, sorry. And what I will do, I will take all this and cut it and paste it inside of this subpatch. And now there is an object which is called switch, which does exactly what I said before. It's really when the toggle is on 1, the processing of this subpatch will be done, and when it's turned to 0, the audio processing will stop. Because here I have my envelope which reach 0 after 150 seconds, but the oscillators keep on working, in fact. But when because volume doesn't imply that the processing stop, so we have to find a way, which is quite straightforward, to use the fact that the volume reaches 0, and then it will send an off message to the switch object. So as this envelope is a signal, I need to change the signal value into a float value, which is done with this object. S2F means signal to float, and then selector 0. It's the same thing as here. And when it reaches 0, it will send a 0 to the switch object. And one might think that the simple way to send a 1 would be this. So when it reaches 0, it sends a 0, and when it's not on 0, it sends a 1. But this doesn't work, because as decay, this envelope is itself a signal. When the switch is put off, the audio processing stops entirely. So no matter what happens, decay in some way doesn't work anymore. So that's where we can simply use one of these bangs, because it's not because the audio processing has stopped that the values from here are stopped. These are, how to say, really datas, simple datas. So these ones, the sequencer will keep on working no matter whether a switch is on or off. So the starting of the note will be the 1, and once the audio processing is activated, it will wait until the envelope reaches 0, and then the switch will work. And I need to do the same for the snare. So let me create a subpatch again. Put this little piece here, and let's cut and paste that. Oops, yes. So here, same thing, and I will use the noise envelope because it's longer than the pitch thing envelope, so this will be the one that will be used to put off the subpatch, and again this bang. So now let's see the result. Let's put the BPM. Okay, I did something wrong. Let me see. Okay, so it seemed that decay, even when it say it would reach 0, it seemed that it goes like 0.0000001, so it's not exactly 0. So I think a great way to avoid this problem is to put an I, which means integer. It will convert any float into an integer value. So normally that would resolve the problem. Now it's even worse. Let me see what happens here. Oh. Okay, so quite frankly I don't really know why this doesn't work, but there is something simple we can do, because we know exactly how many times, what's the duration of the envelope, so we could theoretically use a delay object. Let's see. Okay. Let's do it this way. So I simply take the sum of those two, the attack and the release. And yes, I think it's pretty obvious how this works. So yes, sorry about this little problem. I thought it would work without any trouble, but so here I need to adapt, so it's 110. So let's get rid of this and use this bang here and here. And now we can see before I made a test before beginning this video. It was the CPU was right at 20, and now it's really more. It's really lower, so it's we really use less CPU in total, which will be neat for the next video when we will make a baseline. So thanks for watching, and see you the next time.